right, so let's go through example 2. We're going to find the amplitude, period, and phase shift of the sinusoidal function, and we're going to graph it. Keep in mind that this time we are graphing a cosine function. I don't know why I was so excited about that. Sorry. So amplitude in this case is 4. The absolute value is 4, which is 4. My period is 2 pi over omega, which is 2. So my period is just going to be pi. And our phase shift, you think they would come up with a symbol for that so I don't have to write it out every time. The phase shift is 3 pi over my omega, which is 2. And I remember that because I'm adding, this is shifted to the left, so in the negative direction. So let's go ahead and graph this by using the horizontal shifts. That's what I like to do. So remember that 4, that's our vertical stretch. And that 2, well, by a factor of 1/2, that's our horizontal compression. My graph is shifted left 3 pi over 2, and then it's shifted down, so a vertical shift of -1. And we're going to do that vertical shift last, I've decided. So let's go ahead and graph y equals 4 cosine of x. Well, cosine of 0 is 1, so this is where our graph's going to start. So I've got 1, 2, 3, 4. We're multiplying it by 4 already, so we're going to have 4. Cosine of pi over 2 is 0. Cosine of pi is going to be -4 in this case. Cosine of 3 pi over 2, that's 0. And cosine of 2 pi, that is again 1. So this is what my graph is going to look like. I'm trying to make it look all curvy, but it's just not happening. Then what we have to do is we have to do a horizontal compression of 1/2. So now I'm going to graph y equals 4 cosine of x plus 3 pi, 2x plus 3, just the 2x part. We'll do that next. So now what used to happen in a period of 2 pi now happens in a period of pi. So my whole graph has been squished. So I've got 4, 4, -4, and then at pi over 4 and 3 pi over 4, we cross 0 at those points. Okay, so here's our new function with a period of pi, which is what we calculated. Now what we're going to have to do is a phase shift, and our phase shift is going to be shifting 3 pi over 2, right? Our phase shift is 3 pi over 2 to the left, okay? 3 pi over 2 is from 0 to 3 pi over 2, right? That's where our shift is from 0 to 3 pi over 2. This is our 3 pi over 2, and we're shifting to the left. So this point's going to come over here, 3 pi over 2. This point's going to come over here, right? Everything's shifting 3 pi over 2. So now this is going to be my new function, right? It kind of looks like it flipped my graph over the x-axis, but it didn't, right? We were just shifting it 3 pi over 2. So here's y equals 4 cosine of 2x minus 3 pi. Next thing I need to do is I need to move that down 1. So let me graph that in orange. And I'm going to graph that actually over here. So we have everything on the same page. It'll just be a little bit easier to see. So now where my point is at -4, it becomes -5. Where my point is at +4, it becomes 3, right? We're shifting everything down 1. All my zeros become 1s. Down here, 1, 3, -1. Right, we shifted everything down. So here's the graph of our final function, which was y equals 4 cosine of 2x plus 3 pi minus 1. Last thing I want to talk about, example 3, is finding a sinusoidal function from temperature data. And in order to fit a sine function to data in the data table, you're going to use your graphing calculator and a lot of the stat plot options. There's already an amazing video of this. I did put it in the playlist for our class. It's the next video. So I would recommend watching that video. It's really short, like 5 minutes, and that's going to tell you how to use sine regression in order to fit specific data to a curve. Here's the solution. If you want to check your data once you've watched the video, your graph should look like this.